Yippity yo, howdy boo bop. Today we're going to learn how to solve equations with variables on both sides. This is notes number 13. So, you are going to see variables on both sides. What I mean by that is that you'll see variables on both sides of the equal sign. As you can see, there's a variable here on the left side, and there's a variable here on the right side. Despite that, the name of the game is still the same. I'm just gonna zoom out a little bit. Get the variable by itself. Get the variable by itself. So we're doing solving equations with variables on both sides, and the name of the game is still the same. Get the variables by itself. So how do we do that? Well, number one, we bring all the variables to one side. I want you to underline to one side. And then you bring all the constants to one side. Again, I want you to underline to one side. What do I mean by that? Okay, let's take this example again. We have 5x plus 1 equals 2x plus 7. So that first step right here says bring all the variables to one side. So I'm going to do that. I'm going to bring all the variables to the left side. Okay? So if I want the variables to go onto the left side, I have to make them disappear from the right side. The way I make it disappear is to do the opposite. Here we have a positive 2x. The opposite would be minus 2x. What I do to one side, I have to do to the other. These cancel out. I'm left with a 7 here. On this side, 5x minus 2x equals 3x. And I still have that plus 1. As you can see, all my variables are on the left side. You only see the variable on the left side now. You don't see any variables on the right side. Okay, now for step 2. Let's number this. This is step 1, this is step 2. Now for step 2. Bring all the constants to one side. A constant is a number without a variable. So 1 is a constant and 7 is a constant. So I brought the variables to one side. That means I have to bring the constants to the other side. So if I want to have all the constants on the right side, I have to make them disappear from the left. To make this disappear, I will simply do the opposite. The opposite of plus 1 is minus 1. What I do to one side, I have to do to the other. These ones disappear. They cancel out, leaving just a 3x. Over here, I have 7 minus 1, which equals 6. As you can see, I have brought all my variables to one side. There's only variables on the left side, as you can see. And I have brought all my constants to the right side. There's only constants on the right side. There's no variables over here. Since we've done this, we might as well finish it out. I'm going to draw an arrow over here. This is something that we've seen before and is super easy to solve. Now that I brought all my variables to one side and all my constants to one side, it's basically a one-step equation, which we've done before, which I know y'all know how to do. You want to get the letter by itself. You need to make this coefficient disappear. You make it disappear by doing the opposite. It's being multiplied right now. The opposite of multiplication is division. So I will divide this side by 3. What you do on one side, you do to the other. These 3's cancel out, leaving just the x. And on the right, 6 divided by 3 is 2. Final answer. Something I want y'all to know is that it does not. It does not matter what side you bring the variables to or the side you put the constants on. What do I mean by that? What do I mean by that? Let's read it one more time though. It does not matter what side you bring the variables to or the side you put the constants. So let us solve the same problem, but we will bring the variables to the other side. Okay, what do I mean by all this? So in this case over here, I had brought all the variables to the left side, and then I had brought all the constants to the right side. If I wanted to, I could bring the variables to the right side instead, and the constants to the left side instead. It doesn't matter which side you pick as long as you stick with it. If I choose to bring my variables to the left side, I have to bring all the variables to the left side. If I choose to bring the variables to the right side, I have to stick with bringing all the variables to the right side. Whatever you choose, you got to stick with it. Okay, since we brought them to the left side last time, we'll bring them to the right now so you can see what it looks like. So if I want to bring the variables to the right, I got to make them disappear from the left. To make it disappear, I do the opposite. This is a positive 5x, so I will minus 5x. What I do to one side, I do to the other. These 5x's cancel out, leaving just a 1 on this side. 2x minus 5x, you can put 2 minus 5 in your calculator and you'll get negative 3. Don't forget the x, negative 3x plus 7. As you could see, I only have variables on the right side now. I brought all my variables to one side. If I brought my variables to the right side, then I gotta bring my constants to the left. The way I bring my constants to the left is that I make the ones on the right disappear. This is plus 7. I gotta do the opposite, so I minus 7. What I do to one side, I do to the other. Plus 7, minus 7 cancel out, leaving just a negative 3x on this side. Equals 1 minus 7. 1 minus 7. I start at 1 and I minus 7. I'm taking away positive 7. I'm taking away hot, so I'm going to get negative. 1 minus 7 equals negative 6. You could put that in your calculator too if you are unsure. So again, I have all my variables on one side and I have all my constants on one side. It looks different than 3x equals 6. This is negative 6 equals negative 3x. But in the end, I'll get the same answer. Watch and see. Name of the game is still to get the letter by itself. I do the opposite. The opposite of negative 3 times x is dividing by negative 3. What I do to one side, I do to the other. These negative 3's cancel out, leaving just the x. And over here, negative 6 divided by negative 3 is positive 2. So 2 equals x, which is the same thing as x equals 2. There you have it. That's how you solve equations with variables on both sides.